I am Jose Castaño Verde, I am from Vigo, Spain, and my final project is called Solving Nonlinear Differential Equations by Numerical Methods using Mathematica. To solve differential equations computationally with numerical methods, I have selected the so-called Lorentz system of differential equations, whose solution puts to the butterfly effects his name due to the appearance of his chaotic solution. The system is this, where x, y, and zeta represents the system state and sigma, rho, and beta are the system parameters. The problem needs to apply the concepts learned in CS50 about the declaration and the use of variables and structures and the iteration using while and for loops, saving the data obtained in the global structure called data. The problem requires to print them into the correct file a path for read the data using another software specialized in data representation with his command window. For the computational and mathematical part, we have to discretize the equation system using the definition of a derivative and using the time interval so short so I can get a solution with a good accuracy. The file have to define the initial conditions and the system parameters and obtain x, y, and zeta for each iteration in time. Basically, I print the results in a CSV file and then I use Origin to read this with the command line and represent them in a 3D plot with the correct style. I performed a lot of programs using different initial conditions and I represent some of these results in a 3D plot with the projection of the solution in the theta x axis as we can see in these plots. As you can induce, the form of this chaotic solution and its projection introduce the name of the so-called butterfly effect. Also, I performed programs changing the system parameters and the most important results came from the change of the raw parameter which led us to a stable and chaotic solutions.